Mrs. Blocks, science. Da 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 da.
So today we're describing the bonding in sodium. So sodium is an example of a metal, and we're now going to look at some students' work as they attempt to answer that question. So here the student has started by showing a displayed formula, showing S for the sodium, and then a line to show its bonds. And because they remember doing something like this, they put hydrogens around the sodium. However, they've forgotten that the symbol for sodium isn't an S, it's actually Na. Weird one, but it comes from the old name for sodium. So they then re-attempted that question in the light of the fact that sodium's symbol is Na, but they've stuck with their idea of using a displayed formula for this particular type of bonding. So they put the capital N in the centre and they put the lowercase a out at the edges. And remember that a symbol cannot be split in this way. So if they were going to do that, they should have put Na on each end of each bond. So now we're going to look at another student's work. And this student has made some progress because they've remembered that sodium is a metal. They've drawn circles to show the particles in the bonding. And the particles they've shown are circles with positives in to show positive metal ions. But they've also shown some circles with negatives in, showing that there's negative metal ions. Now they've done this because they've remembered that sodium makes positive ions, and they've remembered a different type of bonding that sodium often engages in, where it bonds with a non-metal. So here we've got more progress again. Now this student still recognises it's a metal, but they've now drawn a regular structure, a lattice, using circles in rows, and they've represented them with circles with a plus over the top of it to show the positive metal ions. They've also shown negative electrons around the lattice, but they haven't quite shown all the electrons they could have. So now let's look at the perfect way to draw and describe the bonding in sodium. So we need to remember that sodium is a metal, and if you're not sure, you can always look it up on the periodic table, find the symbol Na on the left. That means it's a metal. So if it's metal, it's metallic bonding. So we need to start by drawing circles to represent the particles, and we're going to draw them in neat rows, and each circle in the line is going to have a positive sign in it to show that they are positive metal ions. And we'd normally draw 3 lines just to prove we know what we're talking about. And then we have to label the symbol so that the examiner knows what you're talking about. So we label it positive metal ion. Okay. And these are in regular neat rows, so we can describe this as a lattice structure. Remember the word is lattice, and that means any structure that is regular neat rows. So, but that's not complete because we've only got positives and nothing sticks around as positives on its own. So we now need to show the negative side of this equation, and that's the electrons that are spread throughout this regular lattice. So we've just shown delocalized electrons, they're spread throughout the lattice, and we just need to label them delocalized electrons. They can be spread any way you like. And we need to remember that delocalized electrons means that these electrons are free to move throughout the structure. And that's why metals can conduct electricity. And if we're asked to describe the bonding, we need to describe it as electrostatic attraction, because all kinds of bondings are that. And that's between positive metal ions in a lattice structure and the delocalized electrons. And the bonding happens in all directions equally. And there you go, describe the bonding in sodium, metallic bonding.
So one of the things that an exam is likely to ask you to do is to apply your knowledge in a new situation. So here we're looking at an example exam question. They've given you the information about what the question's about to start with, and a little bit of visual stimulus just to enliven your day. And then they've given you a couple of other questions that link back to the stem of the question. However, as questions in exams often do, it starts in one place and then it works through related topics to somewhere else. So here we have silicon dioxide, here we have sodium oxide, which is related, and then we have glass using tiny particles of gold. There's your link into gold is a metal. So that's your clue that we're thinking metals, and as a result, we're thinking metallic bonding. So then we have to work out what the question is asking us to do. It asks us to describe for 3 marks. So if you've got 3 marks, describe means you're going to need quite a bit of detail. So first of all, we need to describe the structure of a metal as being a lattice. A lattice structure is a regular arrangement of particles, and that will give you your first mark. Your second mark is then for saying what kind of particles are involved in this lattice, and because it's a metal, the lattice is made out of positive metal ions. You could use the word atoms, but it is more accurate to use the phrase positive metal ions, and that gets you your second mark. And then the final part of this is if you've got some positives, you need some negatives, and those negatives are the electrons, which are delocalized electrons, free to move throughout the structure. So delocalized electrons throughout the structure. And that gets you your third mark.